Hello everyone, I'm Bhumika Mohan. In this video, I'm going to talk about test of significance for means of two small samples. Contents. First, I'm going to talk about the introduction, then students' t-distribution and its applications. Then I'm going to talk about testing significance of sample mean, fiducial confidence limits of population mean. Then I'm going to discuss some examples. Then test of significance for difference between means of two small samples and some examples. Introduction. For small samples, that is size less than 30, tests proposed for large samples do not hold good, as sampling distribution cannot be assumed to be normal for small samples. This led to search of new approaches to deal with small samples. It should be made rational that the methods and theory applicable to small samples can be used for large samples if the converse is not true. Now, let's talk about students' t-distribution. Gossett, who wrote under the pen name Student, derived a theoretical distribution known as Student's distribution, which is used to test a hypothesis when the sample size is small and the population variance is not known. As size of the sample increases, distribution tends to normal distribution. It is evident from the graph that t-distribution has proportionally larger area at its tails than the normal distribution. If x1, x2, and so on till xn be a random sample of size n less than equal to 30, from a normal distribution with mean mu and variance sigma square not known, also x bar be the sample mean and s standard deviation of the sample, then t equals x bar minus mu by s by root of n, where x bar equals sigma x by n, summation x by n, and s equals root of summation x minus x bar the whole square by n minus 1. Degree of freedom is given by v equals n minus 1. Now, its applications are sample mean, difference between two sample means, sample coefficient of correlation, sample regression coefficient. In this, we are going to talk about the first two, that is sample mean and difference between two sample means. Testing significance of sample mean. Set up the hypothesis H0, that is, sample is drawn from the given population. To calculate significance of sample mean at 5% level, calculate the statistics t equals x bar minus mu by s by root n and compare with the table value of t at n minus 1 degrees of freedom. Let the tabulated value of t be t1 if absolute t is less than t1 and h0 is accepted, otherwise value of t is considered significant and we reject the hypothesis h0. Next, let's talk about fiducial, that is confidence limits of population mean. At 5% significance level, that is 95% confidence level, x bar plus or minus s by root n t 0.05, where t 0.05 is stable value of t at given degrees of freedom. At 1% significance level, that is 99% confidence level, x bar plus or minus s by root n t 0.01, where t 0.01 is stable value of t at given degrees of freedom. Now let's talk about some examples. The example 1, the mean lifetime of sample of 16 fluorescent light bulbs produced by a company is computed to be 1550 hours with a standard deviation of 100 hours. The company claims that the average life of each bulb is 1600 hours. Using the level of significance of 0.05 is the claim accepted. Also find the confidence limits for mu. Solution. Let H0 be average life of each bulb is 1600 hours. Population mean, that is mu, equals 1600 hours and sample size n equals 16. Sample mean x bar equals 1550, sample standard deviation s equals 100 hours. Statistic t equals x bar minus mu by s root n equals 1550 minus 1600 by 100 into 4, that is minus 2. Table value of t at 5% level of significance for 15 degrees of freedom is 2.13. Therefore, calculated value of absolute t is less than table value of t. Hence, the hypothesis H0 is accepted that average life of each bulb is 1600 hours. Also, confidence limits for mu equals x bar plus or minus s by root n, t 0.05 equals 1550 plus or minus 100 by root 16 into 2.13, that is equal to 1496.75 to 1603.25. Now let's talk about another example. Here, the question is 10 individuals are chosen at random from a population and their heights are found in inches as 63, 63, 64, 65, 66, 69, 69, 70, 70, and 71. Discuss the suggestion that the mean height of universe is 65. Value of t at 5% level of significance for 9 degrees of freedom is 2.262. The solution: let H naught be the sample is drawn from the given population. Population mean mu equals 65, sample size n equals 10. Calculating sample mean and standard deviation. Here the table is shown, and the sample standard deviation S equals root of x minus x bar the whole square by n minus 1 equals root of 88 by 9 equals 3.13. Statistic t equals x bar minus mu by s root 10 equals 67 minus 65 into root of 10 by 3.13. That is 2 into root 10 by 3.13, that is equal to 2.02. Therefore, calculated value of t is less than tabulated value at 9 degrees of freedom. Hence, the hypothesis H0 is accepted that sample is drawn from the given population, that is, mean height of the universe is 65 inches. Now, coming to test of significance for difference between means of two small samples, let's talk about this topic. Let two independent samples x1, x2, so on till xn1 and y1, y2, so on till yn2 of sizes n1 is to n2 with means x bar and y bar and standard deviations sx equals root of summation x minus x bar whole square by n1 minus 1 and sy equals root of summation y minus y bar whole square by n2 minus 1 be drawn from two normal populations with means mu1 and mu2 and having same variance sigma square. Then to test whether the two population means mu1 and mu2 are same, calculate t equals x bar minus y bar by s into root of 1 by n1 plus 1 by n2, where s equals root of summation x minus x bar whole square plus summation y minus y bar whole square by n1 plus n2 minus 2, or root of n1 minus 1 sx square plus n2 minus n1 sy square by n1 plus n2 minus 2. And compare with table value of t, say t1 at n1 plus n2 minus 2 degrees of freedom. Hypothesis is accepted if calculated value of absolute t is less than t1. Now let's discuss some examples. Here is example 1. Two independent samples showing weights in ounces of 8 and 7 items are given below. The table is as shown. And is the difference between the means of the sample significant? Value of t at 5% level of significance for 15 degrees of freedom is 2.16. Solution: let the null hypothesis H0 be mu1 similar to mu2. Here n1 equals 8 and n2 equals 7. Calculating sample means and standard deviation, here is the table. S equals root of summation x minus x bar whole square plus summation y minus y bar whole square by n1 plus n2 minus 2, that is root of 28 plus 16 by 8 plus 7 minus 2, which is equal to 1.8. Therefore, t equals 12 minus 10 by 1.8 into root of 1 by 8 plus 1 by 7, that is equal to 2.15. Table value of t at 5% level of significance for 13 degrees of freedom is 2.16. Therefore, calculated value of absolute t is less than table value of t, hence the hypothesis H0 is accepted that mu1 is similar to mu2, that is, difference between means of two samples is not significant. Let's discuss another example, that is example 2. Here, the question is two types of batteries were tested for their mean life length and following results are obtained. Is there a significant difference in the two batteries? Here is the table. Solution. Let the null hypothesis H0 be mu1, which is similar to mu2, that is, there is no significant difference in the two batteries. Here, N1 equals 10 and N2 equals 8, X bar equals 500 and Y bar equals 540, Sx equals 10 and Sy equals 9. S equals root of N1 minus 1 Sx square plus N2 minus 1 Sy square by N1 plus N2 minus 2, which is equal to root of 9 into 100 plus 7 into 81 by 10 plus 8 minus 2, which is equal to 9.58. Therefore, T equals 500 minus 540 by 9.58 into root of 1 by 10 plus 1 by 8, which is equal to minus 8.8. Table value of T at 5% level of significance for 16 degrees of freedom is 2.12. Therefore, calculated value of absolute T is very much greater than the table value of T. Hence, the hypothesis H0 is rejected that mu1 is not similar to mu2. That is, difference between two batteries is highly significant. Now let's discuss another example, that is example 3. Here the question is, a set of 15 observations has mean 68.57, standard deviation 2.4, another set of 7 observations gives mean as 64.14. Standard deviation 2.7. Use t-test to find whether two sets of data are drawn from populations with same mean if standard deviations of two populations are assumed to be equal. Here, the solution is, let the null hypothesis H0 be mu1, which is similar to mu2. That is, there is no significant difference between the two population means. Here, N1 equals 15 and N2 equals 7, X bar equals 68.57 and Y bar equals 64.14. Also, Sx equals 2.14 and Sy equal 2.7. Let's calculate S now. S equals root of N1 minus 1 Sx square plus N2 minus 1 into Sy square by N1 plus N2 minus 2, which is equal to root of 14 into 2.4 the whole square plus 6 into 2.7 whole square by 15 plus 7 minus 2, which is equal to 2.49. Therefore, T equals X bar minus Y bar by S into root of 1 by N1 plus 1 by N2, which is equal to 68.57 minus 64.14 by 2.49 into root of 1 by 15 plus 1 by 7, that is equal to 3.89. Table value of T at 5% level of significance for 20 degrees of freedom is 2.086. Therefore, calculated value of root T is greater than table value of T. Hence, the hypothesis H0 is rejected that mu1 is similar to mu2. That is, difference between two means is insignificant. Thank you.